Okay, hello everyone. Here we have a set which is based on n by n square matrix. Okay, this is a fairly simple set. This is actually a CAT question. This is, I think, CAT 2018 question, 18 or 17 question, but a very easy one. Okay, so let's see what the question is here. You are given an n by n square matrix to be filled with numerals so that no two adjacent cells have the same numeral. Okay. No two adjacent cells have same numeral. Now what do you mean by adjacent cells? The definition of adjacent cells is given. Two cells are called adjacent if they touch each other horizontally, vertically or diagonally. Okay, so let's first draw first question is 3 by 3 square matrix. So let's draw 3 by 3 square matrix over here. 1, 2, 3, 1, 2, 3. Okay, so this is a 3 by 3 square matrix. Each row has there are 3 rows and 3 columns. Okay, so an adjacent cell is, if we consider this cell over here, if you consider this cell here, what will be the adjacent cells to this one, because it touches it horizontally, this cell touches vertically, and this cell touches diagonally. So these 3 are the adjacent cells to this particular cell over here. These will not be considered as adjacent cells. Okay, for this cell only these 3 are the adjacent cells. Fine. What about the middle cell here? What about this cell? Now all the remaining cells, all these 3 plus 3, 6, 7, 8 cells, these 8 cells are all adjacent to the center cell here. Okay, what about the cell or the edge? So we have talked about the corner cell, we have talked about the center cell. What about this cell over here? Which all will be the adjacent cells to this one? Horizontally these two, vertically this one, and diagonally these two. So this cell has 5 adjacent cells. Okay, so this is how we need to consider adjacent cells. Okay, fine. So a cell in one of the corners has 3 adjacent cells to it. A cell in the first row a cell in the first or last row or column which is not in the corner, that means the edge cell over here, has 5 adjacent cells, and any other cell will have, that means either the central cell or any other cell will have 8 adjacent cells. Okay, so let's look at the question over here. First question is, what is the minimum number of different numerals needed to fill a 3 by 3 square matrix? Now adjacent cells should not have the same numeral, right? So let's say we fill in a 1 at this corner cell over here. Okay, now let's fill in the adjacent cells around this cell over here. So let's start with this cell. Now we cannot repeat numeral 1, right? Because adjacent cells cannot have the same number. So we'll have to put in a new number here. Let's say 2. Now let's fill this number here, this cell over here. This cell is adjacent to 2 and adjacent to 1. So we cannot fill in 1 or 2. So we need a third number, let's say 3. Similarly, this cell over here, this cell is adjacent to 1, 3 and 2. So here we'll need a new number, let's say 4. Okay. Now let's look at this other corner cell here. Now this corner cell is adjacent to 4 and adjacent to 3. So this cannot have a 3 or a 4, but it can have a 1 or a 2. This cell is not adjacent to 1 or 2, right? So here we can repeat the number. We can put in a 1 over here, right? Because we have to minimize the number of numbers required. So what we are looking at is, we want to repeat the numbers as much as possible. So we'll fill in this cell with 1. What about this cell? This cell is adjacent to 1, 4 and 3. So, but it is not adjacent to 2. So we can put in a 2 over here. Similarly, this cell here we can put in 1, here we can put in 4, and here we can put 1. So you see what's happening here is, this set of 4 numbers, they get repeated horizontally as well as vertically. If this were a higher order matrix, if this were a 4 by 4 or 5 by 5 matrix, this set of 4 digits will keep repeating horizontally as well as vertically. Okay. So the answer to the first question is 4. The minimum numbers required is 4. You cannot draw the matrix without or with less than 4 numbers such that the adjacent cells will have different number. You cannot do that with less than 4 numbers. Hence the minimum number required is 4 here. Okay. Next question, what is the minimum number of different numerals needed to fill a 5 by 5 matrix? So now, as I was saying earlier, so this was a 3 by 3 matrix. Now if we draw a 5 by 5 matrix, okay, so let's just extend this, and this is also extended over here. So now this becomes a 5 by 5 matrix, 1 2 3 4 5, 1 2 3 4 5, and as I said, these are the 4 digits, right? Now this sequence 1 2 3 4, this sequence if you repeat, so we'll have 1 2 3 4, 1 2 3 4, 1 2 3 4, then we'll have 1 2 3 4, 1 2 3 4 here, and 1 4 1 4 1. Okay, so even for a 5 by 5 matrix, the minimum numbers required is 4 only, right? So nothing changes even for a 5 by 5 matrix. Even if it were a 10 by 10 matrix, the minimum number required such that the adjacent cells don't have the same numeral will be 4 only. Fine? Okay. Now let's look at the third question. Suppose you are allowed to make one mistake, and that is one pair of adjacent cells can have the same numeral. One pair of adjacent cells can have the same numeral. That pair of adjacent cells can be either these two cells, or it can be these two cells, or it can be these two cells, right? So now if only one mistake is required, if one mistake is allowed, so instead of 2, I can write a 3 over here, and the adjacent cells here have the same numeral. But to satisfy for all other adjacent cells, we still need 4 different numerals, right? So here the answer will be still option A, 4, because only one mistake is required. If we had more number of mistakes, if we could afford more number of mistakes, then probably this number would have reduced. But here, since only one mistake is required, this will not, the numerals required will still be 4 only. Okay, fine. Now let's look at the last question here. Here in the last question, again we are talking about a 5 by 5 square matrix. So let me draw a 5 by 5 square matrix. So you have 1 2 3 4 5, 1 2 3 and 4 5 here. Okay, so the question is, suppose that all the cells adjacent to any particular cell must have different numerals. All the cells adjacent to any particular cell must have different numerals. Okay, then what is the minimum number of different numerals needed to fill a 5 by 5 square matrix? Okay, fine. A very interesting question here. Adjacent cells should be different, but a particular cell, so which cell has the highest number of adjacent cells? It's always the center cell. So let's fill the center cell with 1. Now the question says, all the cells adjacent to this particular cell must have different numerals. All these adjacent cells here must have different numerals. So far what we were doing is 1 2 3 4, and then we have 1 2 3 4. So you see, this cell had two similar or two same numerals adjacent to it. Although 2 and 2 were not adjacent to it, but a different cell had the same number adjacent to it. This was allowed in the previous 3 questions, but this is not allowed in this question over here. Okay, so let's see what to do here. All these 8 cells should have different number, and it should not neither be 1. So let's fill this with 2 3 4 5 6 7 8 and 9. So now you see, all the adjacent cells are neither the adjacent cells are same, nor the cells adjacent to 1 have the same numeral, right? All these 8 cells have different numerals. Now, so how many numbers are required so far? 9 numbers are required so far. Now after this, can we start repeating? Let's see. Can we put a 2 over here? Well, let's check. We have a cell of 4 over here. The numbers adjacent to 4 so far are 3, 1 and 5. So 2 is not adjacent to 4. 2 is not adjacent to 4. So yes, we can fill this with a 2. Now 2 9 8. So let's put 2 9 8. So can we put a 9 over here? Yes. 9 is still not adjacent to 4, so we can put a 9 over here. So now here what you see, in the first 3 questions we had a block of 4 numbers that was repeating. Here we will have a block of these 9 numbers that will repeat. Okay, so if this is 298, 298 repeating over here, 234 and 234 will repeat over here, 876, 876 will come over here, and then 456, 456 will come over here. Okay, 298, 298 and so on, 298, 456, so this 6, 456, 456 and so on. So this is going to be the 5 by 5 matrix with least number of numerals such that no adjacent cell has same numeral and no cell has the same numeral adjacent to it. Okay, the question is no adjacent cell should have the same numeral. So no adjacent cell here has same numeral. None of the adjacent cells have same numeral, and no cell has, and each cell, or in other words, each cell has a different numeral adjacent to it. If you pick this cell over here, all the other numbers are different. None of these numbers are same. If you pick this cell over here, all these cells over here are different. None of the cells are same, or none of the cells have same numeral. Okay, so the minimum number of numerals required here is 9. 9 at least are required. More than 9 will also do the case, but what we want to figure out is the minimum number. Hence the answer is option D, 9. Okay, so that's it for the set. Thank you.